Hi everybody, it's Ozzy from Three Monkeys coming to you today from my kitchen in Raleigh, North Carolina. It's a Sunday and I just wanted to do an informal video talking to you guys about our DC solderless system. That is a customizable solderless connective system for wiring the DC supplies on your pedal board. When we came up with this idea, Greg came up with the idea of applying the solderless technology to the DC side of the board more than a year ago. We decided to operate within the constraints of previous technology. So we got our hands on, the various different solderless systems and played around with them to see what we could come up with. Basically, this is the classic. It's a classic side set screw model. It has there's basically two connections you need to make. There's a tip and there's a shield, right? So you've got two connections and you have a cable which is basically a shielded cable. It's like an audio cable or a coaxial cable. It has a core and then a shield, or rather an insulator, and then a shield on top of that, and then a jacket. And what happens is as you insert this cable into the unit, the center core makes contact with a pin to make your tip connection. And to make the shield connection, which is the body or the ground, you have this little set screw here, which you tighten in, and it punctures the shield and makes contact with it to create that connection. And what we found was this is not really the optimal way of doing it, because you basically have two things that are working against each other in terms of their function. First, you have a relationship between the tip and the center conductor that has to be basically concentric. It has to remain perfectly concentric. And then you have this screw on the side, which basically eliminates any concentricity you could possibly produce. So you're sticking the cable up into the unit, trying to maintain it perfectly centered, and then you're squishing it off to one side. What we found with units like this is that, especially when you're dealing with smaller cables like in a DC solderless system, that as you turn this screw, it shoves the cable over to one side and moves the core out of the way of the pin and reduces your connectivity or eliminates it entirely. So what we wanted to do was make a connector that focused on being concentric, maintaining that concentric relationship between the core and the pin, kept a very secure connection, and was easy to use. A lot of people have tried to make a simpler thing, but usually ends up needing a lot of tools. You're going to have to learn how to strip wire. Stripping coax cables, not the easiest thing in the world to do if you're not a tech. You have different jacket thicknesses. The shield itself is very fragile. It takes a while to make one of these cables correctly, and you need a feel for it. You need a feel for the pressure, the torque that you're going to apply to the screw, so it's enough to pierce the jacket and get to the shield, but it's not enough that it's going to force the whole cable to forego its concentric relationships. So what we decided to do was focus on that concentric relationship. So we were thinking, well, what's the best thing that you could do that will always remain, keep the cable in a perfectly placed position within the barrel, securely direct it to the pin without any interference or ability to wander off. It's like a docking station and let's say in a space station. If you're a little off to the right or the left, not very good. You want to be dead center. You want that thing to dock. So what can guide something better in a linear relationship than threads? They've been used for a long time. The screw has been around since the Babylonians, and it is one of the hallmarks of civilization. So we decided to use the screw as our technology. So what we have here basically is our connector. And this connector is a real gem. It's made for us here in the United States by GH Connectors, who've been in this business forever. Great guys and gals. They've worked with us great. They've produced a terrific product for us. It's a solid brass piece, nickel plated. It's like a piece of jewelry. When you feel this thing in your hand, you know where the money went. It's substantial. And the way it works basically is we had to design this cable. So we had this cable made with what would be a shearable jacket. Now most cables aren't used with a jacket that is meant to be sheared. It's meant to protect. It's meant to do all these things. But we found the balance between protection and shear and used it to our advantage. So the way that our system works is the unit here is threaded on the interior and has that, you know, that center pin that we were talking about before. I don't know if you can see those threads, but they're in there. And what happens is, as you insert the cable in, you screw it on. Okay? So you're screwing it on. Now the threads in this unit are now shearing away that insulator. It's actually going to look kind of like a little spiral in there. If you unscrewed it and peeled it off, it would peel off like a spiral. It's pretty cool. So the threads are actually cutting the shield and now squeezing down on that shield to make your negative or positive connection depending upon how your power supply is wired up. It's getting a death grip on it. 360 degrees around. We're not talking about a pin going from the side making it 360 all the way around. Death grip. Very secure. The other thing is, as it's being threaded in there, if the cable's oblong, a little bit off, it makes it perfectly round, as its form is perfectly round. The other thing is, now you have a perfectly concentric relationship between the core of the cable and the center pin, which is making your tip contact. As you screw it on, the cable is moving up in the barrel, and the pin is being driven into the core. So you're getting the most contact you could possibly get from a solderless or a soldered system. It is literally becoming one.